welcome back. We're going to look at some chemical reactions and enzymes today. So we're really going to get into some detail about how chemical reactions take place and how enzymes that are the proteins that are found in the body can help speed up those chemical reactions. So our objectives today, you're going to be able to identify parts of a chemical reaction, so reactants, products, things like that. And then you're also going to be able to analyze how an enzyme affects a chemical reaction. What can an enzyme do to help make the chemical reactions go faster? So let's take a look at these things in some more detail. Chemical reactions. And we've all seen chemical reactions happen before. We know what they are. You take some starting material and you change the chemical composition to form some new material at the end. What we start with is known as the reactants. That is the starting part of the reaction. So you look at the two equations that are listed below. Sodium and chlorine are our reactants for this particular equation. Additionally, copper and sulfur are the reactants for the second equation. The products are what we get at the end. So after the chemical reaction takes place, what do we have at the end? And we have, from the first equation, sodium chloride. And at the second equation, we have copper sulfide. So we get two new chemicals as a result of this. And what's neat is that you get very, very different chemicals. Sodium is a metal, surprisingly enough. Sodium is a very soft metal that you can actually cut with a knife. It's very, very reactive with water. In fact, it's explosive with water. Chlorine is a gas. Chlorine is a very deadly and toxic gas. It's been used to gas people before. So two things that are deadly can react together to form essentially table salt, something that our body actually can utilize and take in. So it's really unique, it's really cool to think about all the different ways that the chemicals can interact and how dramatic that some of the changes can be from the reactants, the starting point, to the products, the ending point. Two different types of chemical reactions. You probably talked about these before. We have endothermic chemical reactions, and endothermic reactions absorb energy. And then exothermic releases energy. So an exothermic reaction, you're going to see, exothermic would be things like explosions. You see a lot of energy being released. When you feel an endothermic reaction, it's cold, all right, because it's absorbing the energy. It's absorbing the energy from the environment. Exothermic, you're going to feel that. It's going to feel hot because it's releasing energy to the environment. So make sure you differentiate between endothermic, absorbing energy would feel cold, versus exothermic, releasing energy would feel hot. One of the things here we want to look at is what's known as a reaction diagram. And reaction diagrams show relative energy in a reaction. So you can see here on the y-axis we have energy, and on the x-axis we have basically time. How long has the chemical reaction taken place? So if we look at that first one, we start off with energy that's about halfway up. And then we input a little bit of energy and the chemical reaction takes place. And you notice that the energy of the products is lower than that of the reactants. That tells us that we have an exothermic reaction because we released energy somewhere. The energy of the products is less than that of the reactants. The reactants is higher than the products. So as a result, we've released energy. That is an exothermic chemical reaction. If you look at the one on the right, that is an endothermic chemical reaction because we've absorbed energy. You notice that the products have a higher amount of energy at the end than the reactants do. So as a result, we have an endothermic chemical reaction. The reactants have lower amount of energy than the products. So we've absorbed energy somewhere along the line. All right, so make sure you're able to identify whether a diagram is either an endothermic or exothermic chemical reaction based upon the reaction diagram shown here. All right, exo releases energy, so the reactants would be higher than the products, and endothermic absorbs energy, so the reactants would be lower than the products. One thing you may have noticed is that there's like this giant, bubble or hump that one has to get over in order for the chemical reaction to take place, and that's known as activation energy. That's the amount of energy we have to put into something for a chemical reaction to take place. So you think about an exothermic chemical reaction like burning a log. The log isn't just going to spontaneously combust. It's not just going to light itself on fire. We have to input some energy. We have to start the fire. That's what the match does. The match, when we put that on there, actually starts the fire, and as a result, all right, the log burns. So that is the activation energy. That's the energy required for the chemical reaction to take place. So that's what the little hump there is for. That shows how much energy is required to get the chemical reaction to go. All right, very few reactions happen just kind of spontaneously without any input of any extra energy. All right, so just some things to think about as you take a look at that. What enzymes do, and remember we talked about enzymes actually make chemical reactions go faster, but how do they do so? Well, they do so by lowering the activation energy. Less energy required for the chemical reaction to take place means that the chemical reaction takes place faster. So you see here on this diagram, without the enzyme, it requires a lot of energy to go from our reactants to our products. But with an enzyme, the activation energy is lowered. So as a result, we have less energy input and the reaction goes faster. That's how enzymes work. They lower the activation energy required for that chemical reaction to take place. So it's a very, very useful tool for our bodies. Most reactions in our body would not happen very quickly if it were not for enzymes. So enzymes play a very important role in making chemical reactions go inside our bodies. So how do enzymes work? We got some definitions we need to know here. The substrate is the chemical the enzyme is going to break apart. It's the reactant, essentially. So we're going to break this chemical into two separate parts. And it would take a long time without an enzyme, so we're going to use an enzyme here. And that is known as the substrate. The substrate then attaches to the enzyme. All right. The enzyme then lowers the energy required to break that chemical bond, and then as a result, it gets released. What's neat about this is that the enzyme can be used over and over and over again. Enzymes do not get used up. So enzymes are very important because they're reusable. So this allows for lots of chemical reactions to happen very, very quickly. So again, the substrate binds to the enzyme, forming the enzyme-substrate complex. The activation energy is lowered, so the chemical reaction takes place, the conversion from reactants to products. You can see that from going from green, which is our reactants, to our blue and orange, which are our products. And then it gets released by the enzyme, and the enzyme can be used again. So enzymes, again, play a very important role in chemical reactions. They can be reused. They help speed up those chemical reactions by lowering the activation energy required. So hopefully by the end of this, you can identify parts of a chemical reaction, reactants, and products, and understand how the enzymes in our body play an essential role in chemical reactions for taking place. So hopefully you know a little bit more about this, and we'll discuss a little bit more about the role of enzymes a little bit later on. We'll do some demonstrations to show you how quickly enzymes can make chemical reactions take place. Have a good day, guys. We'll talk to you later.